are Sejal and Rumaisa. We implemented a single-player Scrabble-Playing Robot with suction for our robotic manipulation project. We were interested in high-precision pick-and-place as we were working with small Scrabble tiles which would be difficult to pick up with a two-finger gripper. Also, we were interested in using a suction gripper for our manipulation. Finally, we thought this would be a fun game simulation for our project. The goal of Scrabble is to place tiles on the game board to form words. As you can see on the left, we have a Scrabble board with the World Tour and a player's holder tiles. These are passed into the Scrabble solver, proposed by Apple and Jacobson, which outputs the best high-scoring word to play. There are 4 components of our Scrabble-Playing Robot. The first component is modeling the Iwa, the gripper, and the game pieces. We were given the models for the Iwa and the gripper, and we catted the game pieces. The second component is representing the internal game state. This is useful for the Scrabble solver, as we need an updated board state to find the next best word to play, and also for deciding our trajectories. The game state includes modeling the board, holder, and the bag. The third component is creating the trajectories. For moving tile pieces to multiple locations on the board and in the holder, we needed to convert the internal coordinates into 3D world coordinates. The fourth component is a finite state machine which integrates these components together. For this, we took inspiration from the clutter clearing example from class.
Here we have the finite state machine of our robot. First, the robot starts off in the solver mode and creates a new word. From there, it goes piece by piece from the holder, picks it up, moves the letter to the board, drops it off, and returns back to the holder. It continues to do this loop until it has played the entire word. Then the robot goes to the bag and picks up a letter and brings it to the holder to refill the holder. And it continues to do this until the holder is refilled. This concludes the end of the robot's turn. The robot will continue to make turns until there are no more words left to be played. Here we have a simulation of our robot playing a game. The robot is picking up the letter T and placing it on the board, and now it will place the letter H on the board as well. In the simulation, the robot always hovers over the letter and then goes directly down to pick it up, and vice versa also for dropping it off. Right now, the robot is refilling up the holder to make its next word. Here is the final game state of the board. The robot has played the word hat and also has played the word ant. For our future work, we would like to introduce multiplayer options where 2 robots can play against each other. We would also like to include passing and challenging to make the game a bit more complex, and include special score calculation and deterministically determine the next word to play. And then lastly, include a real Scrabble holder so that the robot has to come in from an angle. So it makes the manipulation with a suction gripper a bit more complex, but also more realistic. Thank you for listening to our presentation. We hope you enjoyed.